Hey everyone, I'm David Room. Tonight we're going to be doing some more live Python programming and looking at a couple different things. So, first of all, over the past few days, I've been working on some nice Python utilities for doing different things related to video. Some utilities to help me with my YouTube channel, making thumbnails from existing videos, stitching videos together, and doing some new wireframe rendering stuff. So I've done some software rendering of ship models in the past, and I have recently been working on that, kind of taking it to the next level and polishing it up. So I want to talk through some of that because I got some questions about how it worked in the comments on those videos, so that's fun. And then I also want to go on and do a little bit of modeling on some low poly ships. So for the past few weeks, I've been doing a lot of work with high detail stuff, adding little bits and bobs and greebles and bits to my high detail versions of my ships. But I want to pivot back to the game design stuff. Uh, Kind of as we come into the end of the year, I want to make sure to wrap some of that stuff up. And I got a neat comment that brought up something that I've mentioned about my designs, or if I don't know if I've mentioned it, but I've been thinking about, and it got me thinking about how I would implement such a thing, and I thought it'd be kind of a fun thing to try together. So I'm just gonna share quick on Twitter that I'm live, and then we can get started. So I'm having a good week so far. Um, uh, some yard work has been taking up a bunch of my time, but I think that's getting close to done, and I'm looking forward to holing up in the wintertime and doing more streaming and more work on my project. And I'd like to get into doing this more regularly, like maybe a couple times a week. I think might be nice. I've been seeing some growth on my YouTube channel as well, and that always seems to correlate very well uh, with streaming. So, all right. So, let me share my screen, and we'll get into some of the video stuff. So three there's three different there's three different pieces here of new capability that I want to talk about. And let's see here. All right. So, yeah, there's three different pieces of new capability I want to talk about. And they all kind of revolve around some capability that I built. So, I think I showed this off, but a while back I kind of got fed up with the way I had been using FFmpeg, which was to like uh, render a whole bunch of images to a directory, and then basically render a whole bunch of images to a directory, and then run an ffmpeg command on them. It's slow, disk IO is slow. So I built this utility called VideoPipe that wraps some functions from a library called ffmpeg, which basically gives you the ability to have a handle to a process that you that you can write frames to directly with NumPy. So you have an interesting comment here from Jesus Dog. He says Jesus delivered the Bible in JSON. That's funny. So there's actually a GitHub repo. There's a GitHub repo called I think this is it. called, yeah, Bible API that that has Bible translations in JSON form. And I actually used this a while back. I made a project once to do some uh, cool Bible verse images programmatically. So uh, I've actually used this. The script that I use is somewhere in here. I haven't used it for a while, but it's a very nice. The Bible is very nice structured data that works well as JSON. Um, so the way this video pipe works is you can create this pipe process and then start writing frames to it, and you have to specify different parameters. And I spent a lot of time back on this in April, trying to make sure I had good parameters that didn't mangle colors and got good quality and everything. What I realized though is I could write video files, but I couldn't read them. So I had to sit down the other week and implement kind of the opposing set of functions where we can open a process for reading and then read frames into NumPy out of that. So um, so that's what I did. So Jesus Dog asks, have you worked with Manim before? So I have not. I'm very much aware of Manim since I used to watch Three Blue One Browns videos a lot. The problem is I have like a pretty robust set of tools for doing motion graphic type stuff myself. And if I wanted to do the kind of things that you would do with Manim, it might be faster just for me to write it myself using my own tools. You'll see that's kind of the kind of thing that I'm doing here when I get into how I'm actually rendering these wireframes, and I'll make sure to play them so that if you haven't seen what they look like, you can see. So basically, given a NumPy array, we can write it into this write it into this process, and then we can close it when we're done. So this enables some interesting things. Actually, no, this is the reading, not the writing, but we can do both, and you'll see both happening. So the first one of the first things that I built with this is a thumbnail generator, and I actually used this just this evening to make the thumbnail for this video. So basically the way it works is, given an input file, Jesus Dog says, interesting, keep up the good job. Thanks, Jesus Dog. So given a video file, and these are just the 720p ones that I download from YouTube, I load some fonts and stuff and render a title image, and then I read a frame from the video with a certain skip. So basically, let's see, I forget where that skip happens. Yeah, so I can actually read. There's a certain argument to this that you can put that lets you skip a certain number of frames. So I can read frames, and then every frame I composite a title and an image and a subtitle and everything on, and write it out just to a directory. And I can even use a multi-process pool to speed this up. And what you get when you run this on a video is you get some frames that you can quickly page through and choose. I like this one, so I think this is what I used for the thumbnail for this video. So that's a pretty handy utility, and I kind of like just editing files rather than command line arguments. So I can just go in quick. You can see I have different things commented out. I can quickly work to configure the title and subtitle and fonts and things that I want for the thumbnails, and then I can choose one and use it. Um, so yeah, so that's the thumbnail generator. The second thing that I built is uh, a time lapse video capture utility. So the way this guy works is this requires a couple other libraries that I learned about. There's one called MSS that lets you take screenshots of monitors. And so here I'm opening a an, a video to write to with a certain frame rate. Um, you can also capture a webcam if you want a little, face cam while you're doing it. The delays and everything are just specified with constants. It runs, does a screen capture. This is a little bit janky, but it works. Times however much time it takes to do the screen capture, webcam capture, show a preview, write it into the frame, and then adds a certain amount of delay before taking the next capture. So at the end, you have a nice time-lapse video. I'll show what that looks like. I've been taking a few of them. So this is let's see here. I think this is, yeah, this is one from the other day. Yeah, this is the one where I was working on the wireframe videos, and it's really fun to program for a couple hours and then look back at a nice time lapse video and kind of review what you did, think about it, think about what you could do differently. And I've had a couple of these videos kind of take off on YouTube, so I think people kind of like watching them. I find it kind of mesmerizing myself. So yeah, so that's working pretty well. And then the last thing, which I used to make this wireframe video, is a utility that basically can stitch together multiple videos with a title that kind of fades in and fades out. So I've made a couple sort of devlog type videos for my project where I did this kind of thing with DaVinci. Is it DaVinci Resolve? Yeah, DaVinci Resolve. And DaVinci Resolve is just way overkill for stitching a few videos together with titles. So I did what any software engineer does and, write something that does it myself. And this uses both reading and writing to video, like FFmpeg processes, to work. So I think I called this Stitch. Yeah. So basically we have a bunch of input videos, and I had just rendered these with a separate script before I started running this here. For each input video, we open up a process to read from it, and then read frames until we're done, resize the frame that we read to match the output size, and then this is just some logic. So the first 120 frames, or 4 seconds of each video, is going to be the part where the title fades in, shows, and then fades out. So in the first 30 frames, it's going to fade in. The last 30 frames, it's going to fade out. And then the middle set of frames, it's going to be there. So we sort of derive our color with a smooth step function to give a nice little curve to how it's fading in. Render the text with the alpha and composite it. I have some different composite functions and functions for converting between PIL images and NumPy arrays. And then we can run a preview. So then we just repeat for each video. So this would be pretty easy to adapt to any different kinds of videos. I could add subtitles, kind of like I'm doing in the thumbnail, different animations. I think, yeah, I'm doing the alpha fade in and fade out, but I'm also doing a resize where I to squish it vertically. I thought that was kind of a cool effect. And like this is the function that does the text rendering. So I have this kind of convoluted way of rendering text that I came up with when I was still doing a lot of work on Windows, where I actually render the text with Java to get proper kerning and stuff like that. So I'm rendering the text and the stroke, compositing them together, trimming it down to size, and then we can composite it onto the frame. So actually, let me actually just run this. Let me make sure that I've copied out the original in case this doesn't work. I think it's copied out. Yeah. Okay, so and this runs quite fast. Really the only slow part of it running is the text rendering, and most of the slowness there is compositing because it's all done in it's being done in software. You can see here, this is, it's not even flushed yet. I could probably add some commands that flush things more often, but it's not a very big file, so that's not necessary. I think with the time lapse, I figured out a way to flush. Oh, it was just the yeah, it's just flushing when writing bytes. But yeah, so then there we have our output video. It's 100 megabytes in size. And I had some questions about how the wireframe rendering works. So that's a pure software rendering. And so given a triangle mesh, we kind of animate in a camera orbiting, and I place that camera using the dimensions of the mesh in a very simple way. The wireframe rendering itself basically comes up with a whole bunch of segments. So we first derive from the mesh something called a wireframe info, and this is basically just extracting a bunch of relevant things from a tri-mesh representation of the mesh. So we need face adjacency angles, face adjacency edges. These, I believe, all kind of correspond to each other. The normals for each faces, and then centroids for each triangle, which I'm not sure if we actually use the centroids. But when we actually render, which is happening here, and I need to refactor this a little bit. I'd like to just pass a camera matrix indirectly to this function, but we have this function called render segs that given the mesh and that info thing, we get a whole bunch of segments that lie in the 2D plane, and it takes a camera transformation, which is like the extrinsic camera that sort of describes the pose of the camera that should be looking at the scene, and the only intrinsic parameter that we have is a focal length. So we inside here we actually just derive the projection matrix for the camera intrinsic. Transform the vertices, and then we basically come up with sets of segments. And so normally when you're doing hardware rendering, you determine which faces are in front of each other, and are visible, um, with things that are very like GPU and screen oriented. So like the winding angle, or not angle, but like the winding of a triangle. Here we're not looking at triangles. We're looking at edges, because we want to draw the edges of facets of the mesh that are all planar. So we decide we're gonna keep edges. We're gonna keep two kinds of edges, right? We're gonna keep edges where one face is facing towards the camera and the other one is facing away. That's like an outline edge. So if you think about it, like if you're looking at a 3D mesh, the outline of the mesh is going to be all the edges that are between a face that is facing towards you in some way and a face that's facing away from you. So that's the outline. And then other than that, we also want to draw edges that are between these faces. So we basically just test these different angle thresholds, and we come up with a few different sets of segments that we then transform to lie in the 2D plane. So we have a front set of segments, a back set of segments, and a outline set of segments. And then when we do the rendering, we render those in different colors. So I think I'm not using the back segments. We're just using the front, or we're using the front. Yeah, we're using the front segments and the outline segments, because they're not like occluded and unoccluded. They're the edges around things that are facing basically towards the camera versus things that are facing away, and the mesh gets really cluttered if you draw in everything. So that's how the rendering works. We actually do the rendering with Cairo. I have this old wrapper around Cairo stuff that, excuse me here, my nose is really itchy. Wrap around Cairo stuff that probably I could get rid of, but that's what's being used. But it's just all going to a NumPy array. And then a neat thing that happens here is I also do some effects. So you can see in the wireframe there's a little bit of there's like a glow and some horizontal lines. And if you look really closely, there's a really subtle chromatic aberration. So those are also all just implemented as operations on NumPy arrays. So let's see here. That's not right. Apply effects. Yeah. So grabbing the alpha, making the scan line. In a scan line version, basically just zeroing out rows, compositing things back together, adding a little chromatic aberration, which I'm kind of cheating just by doing this really simple shift with NumPy roll, which is just shifting planes of the image, and then a glow, which I think is an OpenCV. Yeah, it's an OpenCV Gaussian blur, and then a max. So pretty simple stuff, but it ends up coming together to make a nice effect. So yeah, that's the video stuff that I'm developing, and if people like the time-lapse videos, I'll be sharing a lot more of those, because it's really easy to throw that on while I'm working on anything. And I don't know, it's kind of cool to see code being edited and visuals happening and stuff. So it's a nice thing. And the goal with the wireframes is just to have, like with with this project, I'm building these assets, and I like to have different ways of rendering them. You know, like I have the game, I've got the high detail stuff in Blender, and then I've got this kind of cool software rendering alternate kind of motion graphics thing. So it's fun to have different outlets for that. So, speaking of models, so I don't know if I can pronounce your name, but I see Jersey says hello. Hello. We have a little project that I'm going to try here, and this just might completely crash and burn, but it's good to put yourself on the spot. So, friend of the channel, Jupiter BJY, had an interesting comment. So I shared a little video, a little short of me looking at the Ashinoko, which is one of my favorite designs that I've come up with. And he had some nice things to say about it, and then said that he'd like to see an armored version of it where the drives are sort of more enclosed in a streamlined body with intake and exhaust holes. So let me just bring up what the Ashinoko looks like. So here's how it looks in the game engine. So it's this kind of triangular ship, and we have these drives in the back that stick out kind of on pylons. And oh, Jersey says this looks amazing. Thank you. Yeah, it's all low poly stuff, but I've put some time into the rendering and presentation of it in the engine. I'm hoping sometime to get back into doing a little bit more shader programming, and maybe share some of that on my YouTube channel and live streams, because I think it's pretty interesting. But so he was saying it would be interesting to see an armored version where the drives are more enclosed. And this is definitely a thing. So this is definitely a thing in my setting where ships would have more enclosed drives. Most of the designs that I've shown don't have them, but that's not really, it doesn't have to be that way. And in fact, I've done a lot of daydreaming about what would be some good ways to kind of build these designs, where I actually build things up from components and then I somehow wrap them or shroud them and derive like a nice body shape from them. So what we're going to try to do is we're going to try to come up with a general way to do that. Now, if it completely fails, I know the method I have in mind completely fails, which it might. I know I could sort of manually create these shapes and manually create a shroud, like even using various constants and measurements and stuff I have. So when I say manually, it would be writing code that kind of lays out a shape. But what I would like to try is I'd like to actually take slices of the ship, do some processing to come up with sort of the shape of a shroud, and kind of derive it from the shape of the multiple components of the ship together without a lot of tweaking. I want to see if that's possible. So that's what we're going to try to do. Jersey says, isn't Python too slow for 3D games? So why not C# plus Unity? Well, a couple of reasons. I mean, first of all, Python is not too slow for 3D games. Let's see if the game is running right now. It might be broken. Whoops. We can do a free flight, I think, probably. Let's see. a while back I changed up all of my keys and I can't remember them for the life of me. So I have to look at the help. Where's my view toggle? Camera. Let's see, is it B? There we go. We're just gonna clip through the shit for now, but so yeah, Python is definitely not too slow for 3D games. There is a lot of stuff that you can do with Python if you use it effectively. And this particular engine I'm using is called Panda 3D, and it is written in C++. So Python is kind of a wrapper for it. So the question, why Python is a good one. So I'm also a software engineer by trade, and I work in AI and machine learning and computer vision. So most of my daily work is in Python. It's kind of what I'm the most experienced with. So I like Python a lot. So I wanted to write my game in it. And I like using open source tools with good licenses that I like whenever possible too. So that's kind of another reason to try Python over something like Unity. But at the end of the day, I don't think it probably would be a ton of work to port my game itself to something like Unity, but that's a project for the future. I have a lot of ideas, not a lot of time. But let's get into trying to build this shroud for the Ashinoko. And let's see if it works. So I'm just going to do this work in my workbench script because I don't even know I don't know if my idea is going to work. And yeah, there's a very good chance that I'm going to make a fool of myself, but yep. Yeah, so Jersey says there's a lot of stuff you can do. Python is an all-purpose language, and if it can be used for everything, it's not optimal for anything. I don't know if that's true. So I get what you're saying, but I think Python is kind of one thing that I would say that Python is kind of optimal for is it's optimal for being a glue language where you can very easily experiment with different things, and then you know, like you can rewrite the parts that you need to be fast in C++, right? Also, I think Python has some really nice principles behind the language itself. So you can actually build pretty complex systems in it, and that sort of principledness of it makes it good as a glue language, right? You know, there's other languages you could do that kind of thing with, like say MATLAB would be an example, or R, but those languages have some other bigger problems. Things that, like design choices that kind of encourage, in my opinion, sort of bad programming. So they're a little bit less than ideal for a lot of things. I'm going to throw on some music while I'm doing this. Some good old White Bat audio. Still need to come up with a better playlist of my favorite songs of his. And you guys have to let me know if the music is too loud. I still need to do a stream at some point where I kind of calibrate audio levels. Okay. So, here's what we're gonna do. Okay. So, for anybody who's just tuning in, I create all of my models with code, right? So, we're gonna run the code here that creates our low poly Ashinoko, and just take a look at it here, and then we're gonna start operating on it. Whoops. Okay, so what I'm going to try to do is I'm going to try to take some slices of this rear part and then use the outline of those slices to build a shroud. Now we want to exclude the radiators from this shroud. So I'm going to try to remove those from the parts here. Parts is just a dictionary, a Python dictionary of basically meshes and transforms that you can iterate over, kind of recursively apply the transforms, and then concatenate together to get a mesh. Let's split this. Just looking up what the names of the radiator parts are so I can toss them out. I think, yeah, they're all gonna have a rad prefix. So when parts is a dictionary, it's pretty easy to just filter, right? So I can go KV for items if not K dot starts with rad. Oops. Okay, now there's one that's taking a parent relationship. I wonder if that's odd. Let's just take a look at our parents here. So the parent is just like for each part what part it's like attached to. And it seems like it's complaining about radiators not being found, so just confused about. Oh, I bet I know what it is. I bet it's, yeah, the shapers. The shapers are those kind of like triangular parts that sit next to the radiator, so I gotta toss those out too. Oh, I can actually use this trick. So starts with can actually take a tuple. There we go. Okay, so we've tossed out the radiators. Okay. So now what we want to do is we want to combine all of the parts together into a single mesh. And I'll take a look at that. Seems like what we expect. And then let's take a look at the limits of this mesh in the Y dimension so we know where to slice. I'm not looking too much at the source that I'm using to build the astronomical because I'm trying to think of you know, sort of a general process for doing this. So let's see here. Y max, max. So we're just looking at the maximum vertex here. The y-axis is always the long axis of the ship. Yeah, 120 to minus 50. So let's say do minus 48. Let's see, we'll do lint space. Minus 48 to minus 20. And we'll do 9 equals true. Yeah, so these will be our slice locations. Okay. Now, let's see what I have for slicing functionality. This has been a little while since I've looked at this. So, slice and mesh, keep only the half on one side. Slice, slice multi. See, I've used slicing a lot before, but I'm not actually usually interested in the points. I'm not usually actually interested in the points around stuff. So I'm trying to think. So if I use these, I'll get a whole bunch of borders, which actually might be what I want, because I could do... Yeah, actually, yeah, let's just try these and see what happens. So yeah, let's just try these and see what happens. So for so we're gonna need plane normal in position. So our normal is always just going to be negative y. It's going to be negative y hat. And the position is going to be just y vector that ends at our y location. Actually, let's just be verbose here. Okay. So slice equals. Oops. I actually need to rename this module because slice is a reserved word in Python. Mesh. Okay. And then we can view this, make sure we're on the right track here. We might be able to get an idea too whether this is going to be a decent approach. Yeah. Oh yeah, we're definitely going to want to get rid of those antennas too. Okay, and we want to go a little farther. We want to go to like maybe... Let's actually go to 16. Yeah, cool. And... Actually, we can get rid of those sensors too. Sensor. Keep things really simple. Nope, that didn't get him. Drive sensors. Let's see here. So we can... Sensors. Oh, this is... not a helpful error message. Okay. Let's see. Oh, the radar is on the sensors, so we got to get rid of radar too. actually, let's see here. Oh yeah. Yeah, okay. So now this is... And actually, I'm going to get rid of that. Yeah, basically we just don't really want any of... a lot of the devices or different components on here. I don't know why I didn't think of that earlier. Yeah. Keep it simple. No... yeah. Because we just want the fuselage itself and yeah, these different shapes. Okay. So now there actually might be... this might actually be easier than I thought, because we don't have another open side here. I think all... I think all of the border points that lie basically on that slice plane are going to be relevant for what we're trying to do here. So let's take a look at those. So we want to find the boundaries of the slice, and these are going to be lists of indices that we're going to want to collapse into just a list of vertices. And we want the actual vertex values. I don't think we're going to care about the connectivity here right now. I think. Yeah. So So this should be a set of 3 points, so let's take a look at it. Whoops. Oh, I know what I did. So just did the whole thing. Ugh. So we want not mesh here, but slice. Yeah, there we go. Okay. Now that's interesting. Oh, I know what's going on. I was like, why? We've got all these extra edges. It's our slice makes some mesh with unconnected with unconnected faces. We've got a process. Do I? Do this. I need a function that does this process retriangulate concat process. Let's see here. Yeah, it's this. Basically this right here. You know what? We're gonna do that right now. Long overdue. Fix slice. Terrible. Okay, now. This should look somewhat better. Yeah. But the question is this gonna be... Oh yeah. Yeah, we've got these extra things here. You can't see it, but there's this markings thing. Oh no, what's going on here? That doesn't look good. Oh, it's just flip. Yeah, it's just flipped around. Okay. Yeah. Let's get rid of that for now. Quick and dirty here. And get rid of the markings. Because those... those are just going to horse things up. it's gonna struggle with that, but you know what? We don't need fix here. I think we can actually just... So there's like different degrees to which things can be broken that you might have to deal with here. And I think we can just do basically just unify vertices. We'll see here. Oh, so Queen of Mud asks a question. How long have you been programming? I'm just learning. So I started programming when I was a little kid, maybe about, I don't know, 7 or 8 or 9. And I am in my 30s now, so close to 30 years. But I probably got into it more when I was a teenager. So probably programming in earnest maybe 25 years, and then, or like, yeah, 20 years, and then professionally for 12 years. So, because I'm a software engineer in my career. So Queen of Mud, what are you learning? Is there a particular kind of software engineering or programming that you're trying to learn, or particular languages or anything? Are you trying to learn Python? I'd highly recommend learning Python because I think it's a really good programming language, and you can do a lot of stuff with it. Yeah, okay, this is gonna work just fine. Actually, just for kicks and giggles, let me look at something, because we might not want to toss out this connectivity information here. Okay, so Queen of Mud says, I'm learning GD script. I guess it's like Python. I want to make a small game. Is GD script the Godot programming language? Yeah. I don't know too much about that language, but I think it does seem a lot like Python. Another one that I think it's probably takes after is Lua, and I've always kind of wanted to learn Lua, but I've never really had a good reason to. So I'm in my day job, I'm getting back into doing some C++ programming, which I haven't done for a long time, and it's kind of a trip, but it's also really fun. When you write C++ code, you can write just a little bit of code, and you really feel like you're building something solid, or just building something kind of scary, I guess. Okay. Yeah. Okay. So this gets all of the vertices with no connectivity information. If we keep it, so I'm just gonna take some notes. Because at the end of the day, what we want to end up here is we want to end up with some nice like surface boundaries that we can connect together to make that shroud shape. And how exactly that's going to work, I'm not sure. It might just naturally not make a nice curved shape at all, or any kind of nice shape, but I wanted to try this and see what it looked like. At least see what we're working with. See if there is kind of a generic way to do this. My plan too is, you know, maybe using something like alpha shape would allow us to do kind of a loose outline with some concavity around each part, and then we could stack those alpha shapes up, and maybe hopefully with a little bit of vertex smoothing it won't look like complete garbage. But we'll see. Okay, actually, you know what, let's just try that first, because I did want to figure out if alpha shape actually gets us anything here. So where is, okay, I'm just gonna try, okay. Yeah. So there's a library called Alpha Shape, and I think that's what we're gonna try first, because I don't know if Tri-Mesh has an alpha shape. Yeah, it doesn't look like it. So if you, the way alpha shape works, I guess, let's get it imported here, is that if you give it an alpha of 0, it will just be the convex hull. But if you give it, you can give it an alpha value that allows non-convex shapes to kind of emerge. We'll see if it likes 3D 3D points or not. I'm gonna try 0 first, and I don't know exactly what this is gonna return, if this is gonna be a shapely shape or something. Yeah, we'll just see. Oops. Okay, so it's geometry line string. Got a shapely, some shapely wrappers. For converting back and forth. It's odd that it returns a line string, because I would have guessed that it would actually return a closed shape. just spacing out here on how to get the points out of a line stream. Oh, that's right. It's just chords. See if this does what we expect. Nope. Oh, I know what's going on here. So we need to use the X and Z coordinates. And yeah, and now we're getting an actual polygon. Okay, so now I can use some of my polygon tools, right? Recently wrote up a whole bunch of wrappers for Shapely. So let's see here. What does this do? Is it just, oh yeah, okay, yeah, it's poly to loop. This is one of my favorite songs in this playlist. I need to move this out opposite to polys. Poly to loop outline. And is this gonna throw a fit if it's a multi-polygon? Poly with holes to loop. It shouldn't have holes, right? It should just have one. There we go. Yep. Okay. So there's our there is our convex hull, right? But we don't want convex hulls. We want a shroud that sort of like follows the shape of the ship, and ideally would kind of like go into this region, right? So let's increase this a little bit here. I have no idea what geometry collection. Come on. Multi-polygons. Now we're getting multiple polygons. Okay. Fail. thought I had some functionality for dealing with multi-polygons, but wow. Exterior. Multi-poly. See, I can make them. Yeah, there we go. Separate multi-poly. So I want to do something like this. And we'll just start to get a little bit more concise here. Henry Ducker says, very cool. Hey, thanks, Henry. Hope you're having a good evening, or whatever time it is, wherever in the world you are. Okay. Now we might have multiple loops here now. So normally when I write code, I kind of like to avoid working with lists of things if it's just a list of things that you're gonna do the same operation on. But I found that when you're talking about slicing meshes or constructing meshes from things, there's like a real analogy between a mesh and a collection of loops. You know, like you can always have faces that have holes in them or different things, so like a collection of loops is way more useful for dealing with a mesh than a single loop. So you often want to work with that set of them. Just like a mesh is a set of vertices and then a set of triangles. That set of triangles kind of implies that there can be this structure. Okay, I see what's going on. So that needs to be way smaller. I don't know. Oh, Henry Ducker says, just finished a MATLAB assignment. Worst software ever created. Yeah, I've used MATLAB in my job a little bit here and there for doing different things. And the thing that really gets me about MATLAB, I'd overlook a lot of other stuff. Like people always talk about the one indexing, it's not so bad in my opinion. The thing that really bothers me is how you can only have one publicly visible function per file. Because what that does is it makes it so that people make these giant files. Because you can only have one function per file. They make these giant files with polymorphic inputs and outputs, and it's terrible. You probably didn't even see that side of it if you were working on an assignment, not trying to read somebody else's MATLAB code. But it can get pretty bad. Okay. Let's see here. So let me bring up this alpha shape documentation because I need to understand better what that alpha parameter is doing. Like, what is the scale of that? More tightly. Bounding box. Mm-hmm. Yeah, MATLAB, it can be written well, but just there's aspects of the language that make it hard. Make it hard to deal with other people's code. Yeah, okay, see this right here. This is what I was hoping to see. Look at that. Hey. I don't know what this... Oh. Shucks. That is... That's from... Oh, that's from retriangulating. Okay, here's what we're gonna do. I always forget why I need to retriangulate. This is looking really promising, you guys. Okay, so... we're gonna go back to this fix. And let me just... I really need to fix that so I can handle holes when I'm retriangulating. But what we're gonna do... What we're gonna do just for now is we're gonna subset these guys. To only keep the ones where we're close to our slice point. So bverts 1. Let's see. What did I call that? Slice y. So only things within, I mean, that should be fine epsilon. And then we're gonna look at this again. Yeah, so there's this awkwardness here where things that where there's can be some failures to retriangulate properly. Yeah, but see, now we're getting the nice... Oh, that's interesting. Yeah, we're getting the nice outlines done now. And it's only going to fail here at the end. See, it's this shape right here. There ends up being a hole. And my retriangulation doesn't support holes. But hopefully we toss these points and only keep these. Yep. Okay. All right. So now, the only real question we have here is this going to look like a total disaster when we try to triangulate it through? So let's... I don't know what's going on, because this is a multi-polygon, but I'm only seeing one, right? Can we just plot the 0th one? And we'll just add it to a list here. catch. Let's back on. Slice. Right. Slice Y. I'm getting excited. We're really close to seeing whether this actually works or not. Oh, interesting. Oh. I mean, I dare say that looks just like I want it to look. Yeah, okay, so one problem here, and just to simplify this so we're not getting into that region. So yeah, so now we can triangulate this. The problem though is that these don't have the same numbers of vertices, which is not a problem in and of itself. We just need to find the right method for turning these into a mesh. And something I guess I wasn't thinking about. Let me think about this. So I've got a function that can do this, but the problem with it is that it might be expecting those shapes to not overlap or sit right on top of each other, and I'm not sure what it's gonna do. This. And even if this works, there's going to be other issues to work through here. Probably going to call it pretty quick here. Whoops. Oh, we've got to reorient these. Yeah, I think let me Let me just check my code here to see if I have... Actually, you know, one thing I could do, I could fake it. I could fake this a little bit. Could add a little tiny scale factor. So that they're not setting right on each other's edges. So 1.0 plus. Something like this. Let's see if this works. Yeah, look at that. That actually worked. What happened here? This actually worked way better than I thought it was going to. Let's reverse the order here. I was not expecting that to actually work. Okay, now we're getting... I don't know what is going on with this. I don't know why we have this being filled in on both sides. Let me flip this. It's actually really cool how it seemed to... It actually even seems to have like correct radial symmetry, which I was not expecting at all. Yeah. I don't know why this one is not connected and why it's filled in. But other than that, this actually... Oh. Oh, we're so close, you guys. I think it's, yeah, because I think it's because this one is smaller. I think we can actually, if we just do this operation in two groups, because basically this triangulate hierarchy operation needs to happen. It needs to happen in a way such that there aren't like overlaps. I wonder though, if I could actually make this more aggressive and then actually I could undo it. That actually might be hard to undo. And again, it might not. If this works, this is actually a really cool technique. You know what? I think I can do this. So we gotta I'm just gonna store the scale factor that I apply. So what I'm doing is I'm scaling each rib out to make sure that we have this nice like pyramid that can be triangulated, and then I'm gonna go back through once we have it assembled and undo it. Okay, now we have to undo this rotation, right? So actually we're just gonna call this route. Mu dot rotate mesh shroud. Yeah. I can't believe that it has radial symmetry. I was not expecting that. Okay, so now we just need to go back through this and modify the vertices. So for scale, let's see here, what do we call it? Slice Y, scale. In zip slice wise scales, which indexes equals shroud. So we're just going to find the indices that lie along that original slicing plane. So where shroud 0 Y, we'll do that abs thing again. Where did I do that before? Yeah. So Y is less than 0.1, and then we just have to reach in there and unscale the XZ by that scale factor. Here we go. So shroud 0, which indices, and then we're going to take X and Z divided by equals scale, and then we'll view it again. Let's see if this works. And then we gotta flip the faces around, and then I think we're done. I think we actually did it, you guys. Oh, what is it not like? Indexing. 33.2. Can't broadcast. Broadcasting sometimes does some kind of unexpected things. Ah, what is with that shape mismatch? Ah. So close. So close. What's going on here? Oh, it's failing right there. 2. Oh, what is going on here? I'm really confused, you guys. Maybe it's just too late at night. Because this should be illogical, and I should be pulling this along the first dimension and this around the second dimension, but it doesn't like that. Why doesn't it like that? And let's try this. So close. So close. 33.3. So why doesn't it like that? Why can't I xy is xz equals xyz? Is there something wrong? Is my whole life a lie? Okay, so that works. I guess it just doesn't like logical indices on one axis, and let's just try. Let me just try one more thing. Nope. Okay. All right, that's fine. Now this better work. I'm not going to be defeated by a simple NumPy issue. Okay, but this is way too convoluted. This should have worked. I'm really curious to try to figure out why it didn't. There we go. There it is. Okay. Can get rid of this flip. Look at that. Okay, and then we're gonna add in those other two. So this is an interesting technique. For triangulating I'm definitely gonna have to use this on some other things. Okay. Yeah, so there it's not aggressive enough. We need to scale more aggressively. I suppose at some point this could really start messing with yeah. Okay, yeah. So I think we're gonna call it here. Basically, we need to take these separate pieces and kind of like bridge them. But this was a really good start on this. I'm kind of surprised the alpha shape thing worked as well as it did. And this technique here for scaling up shapes that have like mismatched size vertices for my triangle hierarchy seems like it might work. Now, like here, if the scaling gets too extreme, we lose our nice triangulation. But yeah, this is something definitely to think about. Let's actually just go back to the shorter range where it does actually work. And we'll just add this piece in with the original ship and see what it looks like. So yeah, see. Actually, you know what? I need to go a little bit farther. Yeah. Well, see, what I'm thinking is with the right smoothing on this, and maybe even further like subdividing or smoothing those ribs that we're generating from the alpha shape, we might be able to get a nice curved covering over that rear part. But anyway, it's gotten really late here. I'm gonna call it good there for tonight, but thanks everyone for watching. It was really fun having everyone in the chat. I'm gonna try to keep doing this regularly, and if you're new to the channel, make sure to check out some of my other videos about my project and other aspects of the stuff I'm working on. But thanks again for hanging out. Thanks for coming, Jersey. Good to have you. And good luck, Queen of Mud, with your GDS or GD script, and Henry with your MATLAB stuff. I wouldn't wish that on anybody. But yeah, thanks again, everyone. Have a good night.